I'm sorry for this inconvenience.
Okay, magnetism and matter. Chapter number 5.
Oh yeah.
Okay, moving charges and magnetism has been over. All right. So see, since it's a very short class and most probably one more student also wanted to do this lesson. So let's start with current electricity. You can switch off your mic. Wherever I'll ask you something, then you can open up your mic.
Sure.
So he has joined, so we'll do it along. All right, class. So see, it's a very short class today, so we'll be just studying. Kinza, just shut your mic off because the noise is just mixing. So we'll just begin with current electricity. Whatever chapters you want to begin with, or whichever lessons are going currently in your schools. So we have different batches out there. Different lessons are going in different batches, and whatever suits you, then you can join that batch. So right now, for a very short class, let's start with current electricity because it's the and Darshan, what about you? Which lesson is going in your physics class right now in school? Darshan, is this audible to you? Okay, it's having network issues. If you are able to hear Darshan and unable to unmute yourself, you can text me. Just tell me the lesson, whichever it is going in your school. So, different batches are going currently.
Yes, ma'am.
Yes, Darshan,
We finished current electricity.
Okay, current
We started
electricity has
magnetism chapter.
Chapter number 4 has been started in school. Fine. So there are different batches out there with different lessons and different timings are there. Whatever suits you people, you can join. So for today's class, I'm just beginning. Let's do just a starting portion of current electricity because that has been covered by both of you as well, and you will be able to understand. Otherwise, we could start with the first lesson also, but that would be very basic. So let's just do current electricity. Now, in current electricity, like in case of electrostatics, when we talk about electrostatics, there the charges are at rest. When the charges are at rest, the first basic quantity that comes is electric charge. In case of current electricity, the charges begin in motion. You talk about the terms like acceleration, you talk about the terms like velocity, which were missing in case of electrostatics because charge just didn't move that time. So right now also in case of current electricity, the basic thing for the whole lesson is electric current. And electric current is also not a new topic. It's also related to electric charge only. So electric charge is actually the basic property, intrinsic property of matter that gives rise to various phenomena. You must have studied of Coulomb's law in your electrostatics. You must have heard of electric fields. So similarly, electric current is also one of the topics that is directly linked with your electric charge. So we'll begin with electric current only. Now, what is electric current? Electric current is basically, or I'll use the term simple current. Current means when you have flow of charges. Means when we were talking about a single charge, that was a different phenomenon. But when more than a single charge that keeps on flowing, we call it as electric current. See, if anything gets divided by time, we call it as rate. You must have done it in your 11th standard also. Rate of change of displacement or rate of change of distance, that is known as velocity or speed. So why did we use the term rate? It's because it is distance getting divided by time. So anything that gets divided by time, we use this word rate. So charge, electric current is also basically rate of flow of charges. Now, what does that mean? It means charge per unit time. How much charge is flowing for 1 second. For example, if I have a wire, this is a thin wire that I have, thin wire like these thin wires, I have a thin wire. So at T is equal to 0, I have connected this wire with a cell and whole circuit has been set up. Now at T is equal to 1 second, I stop the timer. Now I check for the charges. Let's say Q amount of charges have flown for 1 second. It means this term is now current. Charges, amount of charges that have flown for 1 second. Now, how do we prove this? We prove this with the definition of electric current. Electric current is basically charge per unit time. So formula of current also, this is denoted through this capital I, and this becomes Q divided by T. Charge getting divided by time. Now look here, if you put T is equal to 1 second in this formula, what is the relation between current and charge right now if T is put as 1 second? Any idea by looking at the formula? See the formula? Yes, Kinza, would you like to try? If you put this as 1, what will be the formula left?
Current is equals to charge.
Exactly. Current will be equal to charge. Right. So this means what is current? Current is basically the amount of charges that have flown for the duration of 1 second. So we get the formula of current as Q divided by T. That is what is meant by current, rate of flow of charges. Now, direction of current is also decided. Current is what kind of quantity that we'll discuss, but we have a direction for current. Direction for current is very easy. Like in your magnetisms and magnetic chapter, when we move on to magnetisms, we see that direction for magnetic fields have various rules. Right hand thumb rule, Fleming's left hand rule, different rules are provided. For studying current, for electric current, the direction is very simple. If you have a positive charge for the direction, so I'll give you time to note these things. Just don't write it right now. I'll give you time to note on this. So for the direction, if we have a positive charge for a positive charge, the direction of current is same as the charge, as the motion of the charge. And opposite for a negative charge. Now see what does this statement mean. This statement basically means if I have a charge plus Q, this is a positive charge that I have. Let's say supposedly this charge is moving in the right hand side with some velocity v, because in case of current electricity you allow the charges to move. In case of electrostatics, we never allowed the charge to move. The condition was that for any charge, point charge not to move was the condition. Stationary source charge we used to take. In case of current electricity, we allow the charges to move. So for example, let's say a positive charge capital Q is moving with velocity v in the right hand side. So the direction of current for this particular positive charge, this will be in the right hand side only. Had it been a negative charge, let's take the case of a negative charge. Negative charges, you have an electron. So if electrons are mentioned or directly negative charge is mentioned to you in the question, you say, let's say minus Q. Let's say this is also moving in right hand side with v velocity. So the direction of current is opposite to the motion. If the motion occurs in right hand side, the current's direction will be in the left hand side. So this will be the direction of current. This is what was meant by the above lines that was written. That for the direction of the current, that is same as the motion for a positive charge and opposite for a negative charge. Now, few little points before we move on to the question part and rest of the things is the SI unit. See, current's formula is Q divided by T. So what's the SI unit of charge, Darshan? Can you answer this? What's the SI unit of electric charge?
And what? I didn't hear.
SI unit of this electric charge. Do you have any idea?
Coulomb.
Coulomb. Yes, perfect. That's coulomb. So for current, we say 1 coulomb for 1 second because the SI unit of time is 1 second. This ratio, we call it as an ampere, 1 ampere. So basically, we have the SI unit of current as ampere, which is denoted with the help of this capital A, amperes we write it. And another thing is that current is a scalar quantities. See, since we haven't discussed it together, physical quantities are grouped into 2 categories. First is the category of vector quantities, other is the category of scalar quantities. Vector quantities have magnitude, they have direction, and they obey the vector laws. Vector laws means which we have studied in your 11th standard, the parallelogram law, triangle law, polygon law, all those vector laws. In case of scalar quantities, you just have their magnitude and the unit. You don't have the direction. They do not obey the vector laws. Means if you have a scalar quantity like electric potential, so for quantities like electric potential, you don't take out the direction. So that's why we categorize them as scalar quantities. Now regarding electric current, we had seen what electric current's formula was Q by T. That will give its magnitude. But we have just seen the direction. The direction for the positive charge is this, for a negative charge is this. But still we are able to write this as scalar quantity. Reason behind this is that electric current is the only scalar quantity which has direction. So just keep this point in mind that it's the only only scalar quantity that has a direction. But why do we put this under scalar category is that it doesn't obey the vector laws. As you can see about the direction is simple. Reverse it for the negative charge and the same as for the positive charge. So it doesn't obey the vector laws, means all your parallelogram law, all the triangle law, all those laws which you have studied for resolution of the vector quantities that are not applicable for electric current. So that's why we call it as a scalar quantity, but do keep it in mind that they have a specific direction. Now, if we calculate the average current, if we are taking out the average current, so average current can be given by, average current means if I say I have a time interval. For example, I say from t is equal to 0 seconds to t is equal to 8 seconds, tell me how much current flow. So how much current flew for t is equal to 0 to t is equal to 8 seconds, that became a time interval from one initial time to a final time. This time gap between the initial and final time, we call this as a time interval. So if you have to calculate current for a time interval basically means what? For example, I say from t is equal to 0 seconds to t is equal to 8 seconds. This is a time interval. So the formula of current will be delta Q divided by delta T. Means whatever is the change in current, change in electric charge, final charge minus initial charge, that gets divided by the time difference. Means final time minus initial time. What kind of current you get here? Once you take out the current for the time interval, this current is known as an average current. So even if your questions, if you are asked what is meant by average current, do keep it in mind that you just have to calculate the change. Then the next thing comes is time instant. One was time interval, other one is time instant. Now I'm not telling you to calculate the current for 0 to 8 seconds or tell me the charge that has flown from 0 to 8 seconds. I'm asking you, tell me how much charge is flowing exactly at t is equal to 8 seconds. Or exactly at t is equal to 8 seconds, tell me how much current is there in the circuit. So time instant becomes what? Exactly at a particular time. It can be a huge number like 8 seconds. It can be a smaller number like 1 or 2 seconds. It can be infinitesimally smaller number. That means 0.0000 something seconds. A very small number, which we call it as infinitesimally small. So time instant means what? Exactly at a particular time, you have to find out the current. Like t is equal to 8 seconds. Tell me how much current has flown. That time, what do? You differentiate the current, dq over dt. Differentiation, I think you people must have done. If not, we can revise it again. We can have arrange a class for differentiation and integration, because without calculus you won't be able to solve physics if you are facing any issues with it. So I is equal to dq over dt. What did we do? We are not taking the difference right now. We are differentiating it. Means using proper calculus rules, we are doing it. We are solving. And what kind of current you get over here? You get instantaneous current. So average current and instantaneous current. Average current for a time interval that you have, you take out the difference of charges divided by the time interval. For a particular time instant, you calculate the instantaneous current, which is obtained by differentiating charge with respect to time. This can also be said if you have a non-uniform current charge distribution. So that we'll see with the help of question. As the time passes, we'll see the questions also. But before moving on to the questions of this part, I suggest you people to note down few points. Just note down the points till here. Just let me, I'll scroll it down when you have written it. I'll slowly keep on scrolling it. Just note it down. Then we'll discuss some questions as well that come from this formula I is equal to Q by T. And if you have any doubts in between, you're welcome. You can text me your doubt in the chat box, or you can directly unmute yourself and ask me. So is this clear? Kinza, clear to you?
Yes, ma'am.
Darshan, what about you? Clear?
Yes, ma'am.
All right. written this part as well?
Yes, ma'am.
And what about you, Darshan? Done? This
Done,
writing
ma'am.
portion? All right. Let's do some questions on this. Questions based on this topic, electric current. All right. See, the question says that charge flowing through the cross section of a conductor, this is given by 3t square plus 2t plus 1. Definitely non-uniform charge is given. Means if you keep on changing the value of time period, then the value of charge also gets changed. So q is equal to 3t square plus 2t plus 1 coulomb. This much amount of charge has been given. You have to find the current for 0 to 2 seconds, and then in the second part you have to find out current for t is equal to exactly 2 seconds. So current for, let's just begin with the first part. As discussed earlier, 0 to 2 seconds, is it a time interval or a time instant according to you?
Time interval.
Time interval, perfect, because from 0 to 2 seconds you are asked. So how do we calculate? We calculate out the average current, and average current is given by delta q divided by delta t. This is what we get, and we call it as the average current. Now, we have to find out the time difference, not the time difference. Basically, first we have to find out the difference in the charge. Delta Q means what? Final charge minus initial charges. So let's calculate the value of charge at t is equal to 0 seconds, because this is the first time interval that has been mentioned. So at t is equal to 0 second, charge will be what? Instead of t everywhere, just put in 0. So this becomes 3 into 0 whole square plus 2 multiplied by, again there's a t, so instead of t, what are we putting? 0 plus 1, this much coulomb of charge. So this becomes how much? 3 into 0, that is 0. 2 into 0, that is also 0. Ultimately, only 1 coulomb is left. All right, we have found this for 0 seconds. Now what do we have to find it for? T is equal to 2 seconds. So at t is equal to 2 seconds, charge will be what? Instead of t, now we'll put 2 because the time is 2. We're just finding out how much charge has flown for t is equal to 0 seconds. So q0 is this, qt, q2. This becomes 3 into 2 whole square plus 2 into 2 plus 1. So this becomes what? 2 square is 4. 4 into 3, that becomes 12. So 12 plus 4, this becomes 16. 16 plus 1 becomes 17 coulomb. 17 coulomb. All right. So we have the initial charge, we have the value of final charge. But what do we have to find out? We have to find out the change in the charge. Delta Q means what? Delta Q basically means the change in the charge. That means delta Q will be equal to final charge minus initial charge. This becomes 17 coulomb minus 1 coulomb, that gives 16 coulomb. And what about the time interval? How much is the time interval? Time interval will be from 2 seconds to 0 second. Basically, it was 0 to 2 seconds. So 2 minus 0 will give you 2 seconds. How much will be the current? Current will be 16 divided by 2, that is 8 amperes. This is the average current that we'll get. So this is the first part. Note this down and try the second part by yourselves. I'll give you 2 minutes, then we'll discuss the second part as well. In second part, remember, you have to first perform differentiation. Note down the question first. So in the second part, you first have to differentiate, get the equation, put in the value of time there, whatever time has been mentioned, and then see what is the current you are getting. So just do it. Take 2 minutes, we'll discuss it. Don't worry about the solution. I'll discuss it with you. All right, Kinza, don't worry about it. I'll discuss it right now. Just at least note down the first part. I'll help you with it. Okay, let's discuss the second part now. Darshan, did you try the second part, the differentiation portion? Did you try it? All right, all right. Let's discuss it together. See, second part says what? Current at t is equal to 2 seconds. So if you get such kinds of questions, because these questions appear in your board exams as well for class 12. So not even in your, not only in your class 12, but even in your entrances, which you have to appear for after class 12 for any university or in your NEET or J if you're preparing for it. So these kinds of question come. So see, what is the charge? Charge's value is given as 3t square minus 2t plus 1. No, plus 2t plus 1. This is the charge that is given, no? The value of charge. Let's just cross check. 3t square plus 2t plus 1. Yes, this is the value of charge. Now, let's revise the basic rule for differentiation. Differentiation says that if anything is there, x to the power n, that becomes, when we are differentiating something with respect to anything. So let's say x to the power n has been differentiated. That becomes whatever is the power, no, just write it in front of it and multiply with the term that is left. What was the term? X to the power n. So write x to the power n. What was the power? N was the power. Bring n apart from it to get it multiplied. So that becomes nx to the power n. Don't leave your answer here. Subtract 1 from the power. This is what your answer will be. If you have a constant term that is getting multiplied, for example, let's say some constant is there. So keep that constant also along with it. Multiply that constant also. Now let's apply it in our answer. What was it? It is 3t to the power 2. 3 is the constant and this is your function of t. So constant, what did I tell? Keep the constant term as it is. So let's keep 3 as it is. What was the second step? Bring out n. Kinza, can you tell me what is n in this 3t square?
2.
2, exactly. So bring 2 here, and what term is left? T to the power 2 is left. So subtract minus 1. Just subtract 1 from it. So what are we left with? See, dq over dt we are actually trying to bring away because this is our charge. So this becomes 3 into 2t to the power 2 minus 1. Plus, again, 2 is the constant, keep it as it is. This is what? This is t to the power 1. So it becomes 1 comes out, so that will be the whole number still. 1 minus 1 plus differentiating a constant term always gives you 0. These terms were variable. Variable means what? If you change the value of small t, value of the whole term will get changed. But this is a constant term. You cannot change the value. Even if you change the value of anything, this will still remain 1. So basically, when you differentiate a constant term, you get on differentiation it as 0. Is this line clear or any doubts in this line? Clear?
Yes, ma'am.
All right.
Clear, ma'am.
So wherever you are having doubts, you just stop me there and there. So this becomes what? This is 3 into 2 to the 3 into 2 t to the power 1 plus 2 into t to the power 0, and this is 0. This becomes 60. This becomes 2 because t to the power 0 or any constant or variable term raised to power 0, that becomes 1. So this is the value of current. Now, at how much time we had to calculate? We had to calculate it at t is equal to 2 seconds. Just put in the value. Current becomes 6 into 2 plus 2. That becomes what? This is 12. 12 plus 2 gives 14 amperes. This is how you calculate if you are asked to calculate the instantaneous current. Clear? So just note it down. If you have any doubts, ask me. I'm here right now. And what about you, Darshan? Have you written the part? Writing portion?
Ma'am, could you repeat? I didn't hear.
Done. The writing part. I'm just asking you.
Yes,
Have you written
yes.
it? All right.
Yes.
Okay, fine. So since it was a very short class today, so I'm stopping here. If you people have any doubts, you can ask me. Whatever batches suit you, whatever timing suit you, you can just inform. You will be